In this video, we're going to review the Venn diagrams. As many of you know, the Venn diagrams are a visual way of displaying the relationships between sets or different groups of data or elements, right? So when we have a group of data that shares something in common, we put them into one set. So I want us to look at the very first example right here at the bottom. It says that some students who take chorus also takes band, and this is asking us to draw a Venn diagram to represent this statement. So we have students who take chorus, and we have students who take band, and we also have students who do both. So how do we do that? We can use these circles, and we can use this circle to represent those students who take chorus, and then we can use a second circle to represent kids who take band. And where they intersect here, those are the kids, that area represents the kids who do both chorus and band. So that's an example of how we use Venn diagram to express relationships. Now let's go backtrack to the top where it says types of Venn diagrams. And notice these keywords. Oops, sorry, I messed up there. Notice these keywords here. When we have something that's all-inclusive, such as all, always, everything, and then when we apply those to two sets of elements, we're saying that we have one set called P and a second set called Q. And we're saying that all elements of P are also elements of Q. And the Venn diagram is to put the circle of P inside the circle of Q. Okay? And in the next box, we have some elements of P are elements of Q, or sometimes we say sometimes P are also part of Q. So this is how we draw this Venn diagram, and this part in between is P and Q, meaning these elements that I just highlighted with gold, those elements have P in them and have Q in them as well. But if I want it to include all the elements in P as well as all the elements in Q, I use P or Q statement. And the third one, my favorite, is that they don't have anything to do with each other, so they're completely separate. And we use never, none, or no, those kind of language to express that relationship. So there is an all-inclusive relationship, there is a partially inclusive or overlapping relationship, and there's a relationship that does not intersect with each other at all. So now let's look at some examples. Let's look at number 6 first. It says irrational numbers are never rational numbers. So when we have these strong language to negate everything, my best guess is if I draw two circles that never intersect with each other, and one is a perfect square, and the other one is a prime number, and this demonstrates that these two circles, they don't ever overlap, right? So that's number 6. Let's look at number 4. Every natural number is a whole number. So if I have natural number, oops, that's L, natural numbers here, and I should have whole numbers in a bigger circle, right? Because that's how I demonstrate all the natural numbers in the small circle here are also inside the bigger circle called whole number. So that's their relationship. Let's look at number 5. Some vertical angles are complementary. So I have vertical angles, I have complementary, I have two groups. So this represents that these in the middle are the ones that are both complementary as well as vertical. Oops, sorry. we go. So this would be vertical angles, and this would be complementary angles. I'm just using a sign to represent that. Okay, let's look at number 7 and 8. Shade the indicated region on the Venn diagram. I have two sets. They overlap each other, but I only want to shade the Q. So everything in here belongs to Q, right? Right there. That's easy enough. Now let's look at P and Q. So all the elements has to have P in it, and they also have to have Q in it. And that's the part that it overlaps P and Q. So all the elements, our previous example was the kids who take chorus. P was my chorus and Q was my band. So the kids in the middle, they have both chorus and band. Let's look at number 9, P or Q. That means everything in P and everything in Q. So all of these letters, they are either in P or they are in Q. So that's how I express their relationship. Finally, last one, P and not Q. So if I only look at P, let me see if I can do a shading here. If I only look at P, I'm here, right? That's very much P. A little bit, clean up a little bit. There we go. That's my P. But then I can't see this part of P. Oops. This part of P is also in Q. So now I have to get rid of that part of the P, and I have to erase the oops, I didn't do a good job there, but I have to erase that part completely. So my final answer for that is all of these elements in P that's not in Q. That's my answer. Okay? Let's look at some of the examples underneath there. Describe each diagram using a conditional or compound statement. So I have all angles that measure 60 degrees is all of them are in acute angles. So we can say, if I use a conditional statement, it's an if-then statement. So I say if an angle measures 60 degrees, then that's my conditional statement, right? Then it is an acute angle. Okay? Number 12 is very similar. Make sure you finish it on your own. Number 13 is different. Remember, when we have overlap, we choose keywords sometimes or some. So in this case, we're talking about volleyball, people who do volleyball and people do piano lessons. So maybe in this case, we can do a compound statement. So we can say some people play volleyball, and that's my indication that this is a compound statement. You don't have to use capital letter. I'm just exaggerating it. And they take piano lessons as well. That's how you express this part that overlaps both sets. Okay, let's look at number 14. Number 14, what's shaded is only part of months with 31 days. But what's this part that's left blank that I am shading with blue is belonging to both month with 31 days and month that starts with J. So that's not included, right? So, okay. So then the statement is the month. This is a compound statement. The month, so this part, the gray area represents the month with 31 days, just like what's stated underneath the circle, but or and do not start. Do not start. It's negating the second circle with J. Right? So July is starting with J, for example. Let's look at number 16. Now we have everything shaded, everything multiplied by 7, and everything that's an even number. So, and I think I just gave you the answer. You say number, make the first statement of the first circle. Those are numbers that are multiples of 7, and they're also even numbers. So that's what that chart represents. Okay, now let's do some additional practices. I won't do everything on this worksheet, but I'll do a couple of examples so that I can lead the way and show you how it's done. Okay, so let's start with number 1 is pretty self-explanatory. Number 2, the Venn diagram below shows the number of people at the gym signed up for yoga and aerobic class. So what we see is 68, 24, 89. So people who do yoga are 68 plus 24. People who do aerobics are 24 plus 89. And the people in between here, those 24 people do both. Notice that there's also a number right here, 575, and that's people, this rectangle shape represents all the people that belong to the gym. So those are the people who use the gym, but they don't do yoga, nor do they do aerobics. Okay, so let's see how do we answer these questions on the right. The first one, how many people are signed up for yoga class? So in that case, it would be 68 plus 24, and that should be 92 people. B, how many people are signed up for yoga or aerobics? So that's 68 plus 24 plus 89. And that comes out to be 181 people. C, how many people are signed up for aerobics, not yoga? So aerobics, not yoga, is right here. Is this this portion here. Right? So that would be 89. That's a straightforward number from the chart. I didn't do a good job with the chart. If I'm a little bit more artistic, I'm messing it up actually. Let's see. See, I can be a little bit more delicate. There we go. That's better. That part represents 89, right? And how many people belong to the gym? So in this case, you have to add the people who only do yoga, add the people who only do aerobics, add the people who do both, as well as everybody else who uses the gym but don't take yoga, don't do aerobics. So I think that comes out, my calculator comes out to be 756. So that's number 3. So notice that, make sure that you understand how to get to each piece of the Venn diagram. Let's look at number 4. The Venn diagram below shows the number of sophomores with Facebook. So Facebook is here. Facebook is here on the left, and Twitter and Instagram. So 3. Notice that there's a number 28 here, and that's the number of sophomores who don't have any of the 3 accounts. So Let's see, how do we answer those questions? How many sophomores just have a Facebook account? And that's very straightforward. If you look at the part of Facebook circle, the part that doesn't intersect with anybody else, those are the people who only use Facebook and nothing else. They don't have a Twitter. They don't have an Instagram. Number 2, how many sophomores have a Twitter or Instagram? So when we're talking about Twitter, everybody in Twitter is 37 plus 46 plus 21 plus 16. That's everybody who uses Twitter. And then because it's a or, we also have to add everybody who uses Instagram, which is 55 plus 34. We should add the 21 and the 16 back, but because we already added here, I don't want to double count them. So that's my answer. If I add these together, I should have 209 people. That's the answer for this. 209. Okay? All right, C. How many sophomores have Facebook, Twitter, and Instagram accounts? So we're looking very specifically for an area that overlaps all three. And if you look carefully, it's this little red corner here. These 21 kids in there, they have all three. They're part of Facebook circle, they're part of Twitter circle, and they're part of the Instagram circle. All the other numbers represents either one of the circles or two circles. Only these 21 kids represents all three circles. So the answer is 21. D. How many students do not have a Twitter account? So then you just need to add everybody outside the Twitter circles. It's 124 plus 55 plus 34, including the 28 kids who don't have any of the accounts, right? So that should be 49. So it should be 241 kids. And finally, how many students do not have a Facebook and Instagram account? So we first need to find out the kids who do have Facebook and Instagram. And if you look at where I mark the blue markers, that 55 and 21 kids together, so it's 76 kids that have both, right? So then since we are negating this part, we're looking for everybody who is not in there. So the simple calculation is 124 plus 37 plus 46 plus 16 plus 34 plus the 28 in the end. That's your answer, and the final answer should come out to be 285 kids who don't have a Facebook and Instagram account. Okay? This is a lot more complicated with 3 circles. So I'm gonna demonstrate how to do number 5, and for number 6 you can do it on your own. So the Venn diagram below shows survey results of cities visited by group of people on a recent trip to Europe. So there are people who went to London, some people went to Paris, others went to Dublin, and there are 78 people who didn't go anywhere in Europe, and they're represented here, right? And there are also people who went to both Paris and London, both Paris and Dublin, both London and Dublin, and there is only 24 people who went to all 3 countries, and that's right there. So that's how you read the how you read the Venn diagram. So let's look at the first question. How many people visited Dublin or London? So because of the or, you have to add all of them together. So Dublin, I have 43 plus 24 plus 31 plus 76. And for London, I already have 24 and 31, so I need to add 64 and the 89. And so altogether, your final answer is, your final answer is 327. Okay. So number 2, how many people visited London and Paris? So we're looking for that overlap, which is 64 plus 24 equals 88. C, how many people visited London or Paris? So this is a lot bigger. So that includes people who has been to either Paris alone or London alone, as well as people who have been to both places. So that is, let's see, I would add 89 plus 64 plus 24 plus 31 plus 43 plus 95. So the final answer is 346. D, how many people visited Dublin and not London? So Dublin is 76. I have 76 people who visit Dublin, but they cannot be, those 76 are not in the London circle. But there are 3 other numbers, 43, 24, 31. 24 and 31 have already visited London, so I cannot include them. So it's 76 plus 43, and that comes out to be 119. How many people only visited Dublin? Finally, an easy one. 76, right? Those are the people who don't overlap with anybody. How many people visited Dublin and Paris? So I'm looking at that overlap, which is 43 plus 24, and that should equal 67. How many people visited all 3? In my introduction, I already mentioned, I highlighted the 24 here. As 24 people who visited all 3. How many people visited London? And that's not hard. That just adds, you can just add all the numbers in the circle labeled as London. And I think it's 31, right? And that comes out to be 208 people. Finally, how many people took the survey? So now you have to add all the numbers together. 64, 24, 43, 31, 89. What's the next? 76, 78. So you add all of them up together. That's a 95. You have 500. Okay, so that's how we use Venn diagram to help us identify different groups, different sets. So give it a try. Make sure that you feel free to pause the video, rewind it, and go back and relearn it if you don't understand anything. Thank you guys. I'll see you in class. Bye.